All right, 12.4 deals with what's called standard deviation. That's kind of the bulk of what we're going to talk about. But before we get there, there are some other measurements that we want to discuss. There's what's called the range of a data set, and then there's also the interquartile range. The range of a data set is the difference between the highest and lowest values. The interquartile range is the difference between Q3 and Q1. Those are the quartiles that we talked about in the last section. If we use the data set from the 12.3 notes, so those were those numbers of 16 through 30, the range would be 30 minus 16, which is 14. The interquartile range would have been 29 minus 18 equals 11. And again, we're getting that information from the 12.3 notes, so if you want to refer back to that. So that's how you find range and interquartile range. It's really easy. And if you do your one variable stats from section 12.3, when we did that on the calculator, that gives you all of the information that you need. Now, another commonly used measurement is the standard deviation. Standard deviation measures how much the data values vary from the mean. There's a formula that you could use to find it, but it's fairly extensive. So we're just going to use our calculator because, again, if you put your data values into your list 1, go back to your home screen and then do the one variable statistics, when it brings up all that information, what you're looking for standard deviation is you're looking for this little sigma x. And so if we were to take this information here using these data points and plug it in and do standard deviation, we would get 5.058. Now, with standard deviation, one of the things that you'll use is what's called a z-score. What a z-score does is it measures the number of standard deviations that a value is from the mean. The way that you do that is you take x minus x bar over sigma, where x is the value that you're looking at, x bar is the mean, and sigma is the standard deviation. So think of it like this. Let's say that the class average, let's say our class average is an 87. Well, some of you are below the 87, some of you are above the 87. So depending on what the standard deviation is, some of you might be 1 standard deviation below the mean. That would be like a -1 z-score. Or maybe you are 2 standard deviations above the mean. So you're at a +2 z-score. And so it's possible to have negative z-scores and positive z-scores because some values are going to be less than the mean and some are going to be greater than the mean. So let's say that we have these class averages. I want you to take a moment. I want you to put this into your L1. And we're going to go through and we're going to find all of this stuff here. So if you want to pause so that you can put everything into your list. And then when you go back to your home screen, you need to do the one variable stats and press enter so that all of that information comes up. So again, if you want to pause, that's fine. So once you've put everything into your data set, and then you do the one variable statistics, that's going to tell you that your mean is 80.154. Your median is 77. Notice that nothing's been repeated, so there is no mode. The range would be 100 minus 54, that's 46. The interquartile range would be 93.5 minus 70.5, that's 23. And then standard deviation would be 12.781. Then there were some questions that I asked you. Also, I said to find the percentile ranking for the person who has an 88. So for the percentile ranking for the person that has an 88, you count how many numbers are there from 88 and less than that. So how many numbers are less than or equal to 88? That would be 9. Out of how many total? 13. 9 out of 13 basically gives you the 70th percentile. So if you think about what we talked about with percentile rankings, to be in the 70th percentile means you're better than 70% of the people, but 30% are better than you. And you may think, well, if I've got an 88 in the class, like that's good. You're right, it is good. But it could be that 30% are still better than that. Then I've asked you to find z-scores for the person that has the 74 and the 95. Notice that 74 is less than the mean, so you should end up with a negative z-score. 95 is greater than the mean, so you should end up with a positive z-score. So to find z-scores, we're going to take 74 minus the mean, 80.154, divide by the standard deviation, 12.781, and that gives us the z-score of negative 0.481. And then do the same process for the 95, which gives you the 1.162. Your homework's on 672. Again, just follow the steps on the calculator and follow the information that I've given here.